Okay, this time we're going to be working on the toy factory, Santa's Toy Factory, and it is from Mr. Christmas. There's the sticker on the bottom. It doesn't have a year. It's an interesting little piece. It's having a problem with the belts, the conveyor belts, these two here. You turn it on, which is actually pretty cool that you use that to turn it on. You can see this is now moving, and now that's moving, and they stop. So, I have a funny feeling that it's probably, those who've never seen this before, you can see the gear in there rotating, and the gears over there are rotating. You see inside. The guys up here are moving, the L's, but the belts are slipping. So something on the drive mechanism for the two belts is slipping, and it's probably another gear. I still like the fact that the off-on switch is actually integrated into the unit itself and not just on the side where the volume is. That's actually pretty neat. So I'm going to plug it. See what we can do to get this fixed. It can be a little slower than normal as I have dislocated my thumb and had it reset, but unfortunately it's torn the ligament, so I'm down to 1 and a partial hands. But we're still going to work on it. Just be a little slower. On the bottom we have 6 screws, and there's the speaker. And the screws are Phillips, which is pretty standard for Mr. Christmas. One of the nice things about Mr. Christmas is they use screws, and they're pretty standardized on how they are assembled and disassembled. Wrong size. If you ever decide to hurt your hand, make sure it's your non-dominant hand. So. One screw. Two. I do have a little bit of strength in my thumb, but the damage is down by the palm, so the tip of my thumb still works, which is kind of nice. I can get at least a little bit of a hold grip. We got 3. Here's number 4, which doesn't want to come out of the hole. There we go. And this is a 6-volt DC unit. Might as well give you the specs on it in case you lose your adapter. It's 6 volts DC. It has the center pin is hot. The buttons on the side here is to change the song. This button here, and there's your volume knob. Now, Like I said, I like the way they integrated the off-on switch, which is a nice way to do it, where you stick it up in on the deck. There's the last one. But I think it would have been cool if they integrated the button and the volume knob as well somewhere in this, you know, maybe on the back of the machine or another wheel over here. Just because they made this look so mechanical. But at the same token, this base where they have the button arrangement and the power arrangement is pretty standard on most of Mr. Christmas things. They use the same basic wheel, power, button, song select setup on most of their units, and they're always side by side, so they're pretty obvious and they're easy to get to. Okay, there's the bottom, and I'm going to say it's probably going to be, at least part of it's going to be this drive belt, because this guy is stretched. Look at that. There's a lot of slack. Hopefully you can see it. So I'm going to have a funny feeling it's going to need a new drive belt. So I'm going to plug it back in, and we're going to test it, and I'm going to have it turned over a little bit. So where to put my power? Right here. And I'm going to stand up so it's a little bit easier to see in the camera when I flip this over. It keeps going off camera because I have to get it to the edge of my bench so I can grab it, just so you know. The belt's really loose. Carefully. There we go. So this motor is driving everything. You can see the belt is bouncing. It is really loose, but we can see that these belts aren't moving. So it looks like the next step would be to unscrew the top, pull it off. Let me turn it down so you can hear me better. Probably still end up replacing this belt because this thing's got a lot of slack and it's bouncing. You can see how much tension I can push on it. So I'll see if I have a belt that will make it still function that's a little bit not as worn out. But these guys, the drive gears are turning. They're right there, which drives these belts. So when the belt stops, the drive gears are still spinning. So something inside this area on the top, we have to take all these screws out, has failed. It's probably another drive belt, I'm going to assume, that has broke free. Or there's a drive gear that's on a shaft that the gear has broken free from the shaft. It has separated from the knurling of the shaft, causing it to lose its traction. But if your main drive belt goes out, it's just 6 screws. It's right there. You don't even have to take the housing off. It's very simple. They actually did it easy. So we're going to kill the power, which is right here. They use a standard switch with a rocker on it. If you ever installed an outdoor light switch cover, it's the same setup. There we go. Take that off. If you ever have to replace a speaker, it's one of the larger ones, but it's a 1/2 watt, 8 ohm, which is pretty standard for most animated electronics that have audio like this. Here's your circuitry. There's your blob trip. And if that thing burns, nothing's going to work right. If you lose this, let's say this does burn, especially this part, you can replace those discrete components by matching up the numbers. But if this burns and you don't want to throw this away, you can still drive the motor and you can make the lights work. You might have to have a small circuit to make them flash like they do, but you can actually still salvage a lot of these houses. Similar to what I tried doing with the Scaricel from Lemax, the one that all the components inside burned. Wasn't able to salvage the audio, but was able to salvage the motion and the lights. So, all right, well, I'm going to go get a little magnet for all the screws. and then I'm going to unscrew the entire top of this. And because I'm a lot slower with my bad hand, I'm going to do that off camera just to save so this video is not 4 hours long. Since you saw how long it took just to take 6 out, imagine how long it's going to take to get, I don't know, 1, 2, 3, 4, 5, 6, 7. I have to take the circuit board out. 10, 12, 14. There's about 14 screws I'm going to have to remove. And while I'm doing that, I got to be careful not to drop any of this and break it. Plus, there's wires inside because these lights light up. And then this drive belt's just a, it doesn't do anything except make this turn so it looks like it's moving. This drive belt is really sloppy too, but it shouldn't necessarily be tight. As long as it's tight enough that when this drive turns this, you're good. So if this ever breaks and you have this toy factory, unless you care about the color, one of those thin, loose rubber bands that they like to use these days on like produce and stuff would work fine, because you just need enough friction to turn the wheel. You can try and find a belt, but you want to make sure this belt has some slop. You don't want it super tight because you'll flex this shaft. I can move it with my finger. You don't want to flex this shaft because you'll end up binding it right here and then it'll start to slip. So sometimes belts on these animated pieces are not used as a full movement. They're there just to make it look pretty or more animatronics, but no tension, no resistance on them. Like on Mount Gloom Observatory, the gears on the outside of the Limax piece, they serve no purpose except to make it look cool, and their drive system's very basic. And if you put tension on them, you'll break them. Like if you put tension on this, you can break this big wheel. So you don't want anything too tight. So I'm going to take the bottom off, and I'll be back in just a moment when I have this separated off to the side, so that way we can see why those two pulleys, those two belts, don't work. Be back in a moment. Okay, got the top off. There is 4 screws, the outer ones, but you have to remove the drive motor mechanism from the bottom to get to the screw that's behind here. So I put the motor mechanism back in so I can turn it back on. If you pull the green wire, pull all the slack out. Don't yank it, you want to break the circuit board. There's enough room to lean it off to the side. You do have to take the belt off this bottom pulley so you don't snap it, don't forget. But now that I can see the gears that drive this, you can see I can turn this, but yet the gears aren't turning. And I can turn this, but the gears aren't turning. There's 2 things I found. One, these packages are loose, especially this one, and as it rotates this way and gets stuck in this groove. So I got to see if it's screwed on and the screw's loose. But this gear and this gear are both cracked. These are the gears that are pressed onto the shaft that drives these 2 belts. So that's why these were spinning and the belts weren't. These 2 gears have cracked. We're going to turn it back on. You can see it's driving the one belt but not the other. And now it's stopped. Now it goes. Now the crack is somewhat important because the crack may cause it to slip. But the other issue is if it's slipping here, it shouldn't be turning this gear. So I think the crack is more superficial on this side than this side. This side, the shaft, which you can barely see between the gear and this plastic wall, the shaft is not turning. But then if I do this, now the shaft is turning. And then the shaft stops. So this side, I believe the reason it's failing is the crack. The crack here might be part of it, but there's something wrong underneath the belt itself. Right in here, there's a drum that's supposed to catch, and it's not catching. And then it stops. You gotta make sure none of your presents are turned that way. That's very important. So this side I believe is a broken gear. This side I believe there's a problem with the drive drum that's inside. Maybe one of the, sometimes the drums are tacky, sometimes the drums have little belts on them to help grab the rubber, so rubber on rubber gives you more grip, and that might be the cause. Now these conveyor belts do unscrew, and click. I haven't gotten that far because I want to show you where I'm at and the process of elimination to get to it. So this screw, and then there's two under the circuit board. This screw, and those two, and this one of course is under the drive assembly. That's what hold on the conveyor belt. So there's 4 screws. To do this removal, which I screwed back on, and I put all the screws back in it for torque. As you can see, there's a lot of gears in here, and it transfers the motions from rotating to linear in 2 different places. So to keep the torque good, I want to make sure all 4 screws are in. You just remove the screw in here, this screw, and this screw you just loosen. It's a pan head screw, and that's your alignment screw. So you take those 3 out, and then this one you can just walk out and lift off, and then let it hang on its slack or put it off to the side so you don't break it from the circuit board. So what I'm going to do next is try and carefully set this down again. Try and wedge the hole so it doesn't put any pressure on the ladder or the figures, because it's all plastic and we don't want it to break. And we're going to unscrew this again. I didn't torque them, I just put them in snug. So if you have a piece of foam or a block or something, you can put it on to allow protection, maybe a rolled up towel, something of that nature. I want to show you how to take this off, since I did it off camera because I'm a lot slower with the hand brace. Those 3 screws are now out, and then this one right here, you just loosen maybe 2 or 3 turns. You lift this, try and get the other screws out. A pair of pliers or tweezers to grab them. That's why these are here. There you go. That way you don't lose them. So there's the drive assembly. And then you can get to the screw right here that's underneath for holding on the top. The drive assembly, it has 4 gears here and 3 gears here. These are large tooth gears. They're all intact. They're not split. All the gears here are good, including the notorious 10 tooth that breaks isn't broke. The only thing I don't like is, again, is the amount of slack in this belt. You can see it's bowed because it's stretched. Once everything's fixed, if this belt is slipping, I will replace it. I'll probably replace it anyway, but I want to test it. I think the reason this belt's not slipping with its bow in it is due to the fact that there's not a lot of pressure because the belt doesn't continuously, the 2 conveyor belts don't continuously spin. So this is the side that has the most problems, and there's 4 screws. So let's see if we can get those out as fast as possible. And on the magnet, I'm using different faces for different screws. These are thinner, smaller diameter screws. So I'm going to put them on the other side face. The motor screws are on the end, and then these 4 screws here are the screws for the house. And then the screws in here are the screws for the base. A lot of them use the same screws. This one uses about 5 different types of screws. Go. And that straight off. So there's your conveyor belt assembly. And now that I have it off, let me see if I can get this crack to show on the camera. It's a hairline fracture in the nose of the gear. I don't think you're going to see it, but there's right here where that nose sticks out is a hairline crack. But like I said, I don't think it's too much of a problem because it's driving this bigger gear on the other side. But if I have a gear, I'll replace it. If not, we'll put a dab of glue on the crack to stop it from spreading. Alright. We need to pull the gears apart, so we're going to walk that one off. We're going to walk this one off. This one doesn't appear to be cracked, since this and that are the same gear. That one is. And now I'm going to see if I can get the pulley to slide over off the side. It's be a heck of a lot easier with two hands. And these are screwed on, so we can tighten the screw on these packages to get them to stay. These are pressed together. I'm trying to get them to separate. It's very similar to how Lemax does their conveyor belts on their Christmas and Halloween factory. The conveyor system comes apart. Just that they're pressed on. So there we go, starting to move. Alright. This side has separated. I can pull it apart. There's two pins that go straight through here, right about this cap and this cap, which the one has separated, this one's still stuck, and then the press that's right here is really tight, which I understand. It has to be a tight press so that the belt gets driven, and then that doesn't just spin the gear like that. So, and I don't have the hand dexterity to keep prying on it. And it's moved, but it's not moved far enough yet. So I'm going to go put this in some soft jaw vice grips, or a vice with soft jaws, and see if I can get a little bit more leverage. So I'm not trying to hold and pry. All I have to do is worry about prying to get the pressed plastic off. So we can check the drive mechanism and tighten the belt, or tighten the screws on the belt so the packages don't spin and get caught in this track. So a lot of grease everywhere. All this reflective stuff is not glue. This is the grease from all the gears. So hate to do it. I gotta pause again so I can go use a tool to compensate for my hand at the moment. I'll be right back. Okay. Before you try and pry it open, after looking at it closely before I put it in the vise, these two pins come out. The only reason I noticed it is when I was trying to get this to separate from the drum, this pin had a gap. So I used the spudger right here and was able to get underneath it. And down inside those holes are actually the holding screws. So unlike Lemax, at least some of Lemax, this isn't held by pressing. This one actually has two screws that are deep down inside. And they're little. So don't try and pry it. That's why I was using small stuff to pry, just in case. And the only way I figured it out was I actually pulled the belt back and was looking at those pins I was telling you about that I saw. And I saw that one of them is somewhat translucent, and I could see threads. So apparently, if you do have this piece, and you have to take it apart to check inside here or replace one of these big gears, it comes apart this way, or to tighten your packages, since these all need to be tightened. You will still have to pry off one side, so don't get me wrong on that. Alright, this uses teeth. There's little teeth on these pulleys, so it's different than Lemax. Of course, Lemax, Department 56, and Mr. Christmas are all different, but these little teeth grip the inside of the belt. And on the inside of the belt, so we're going to invert this thing. So now all the packages are in. You can see the tracks, and you can see where it's been gripping, where it's got teeth, and then there's smooth spots where it's been slipping. So the problem is most likely this belt is losing its ability to grab those teeth. The belt's probably stretched, and that's a problem. I'm going to tighten these packages real quick so they're all the way they're supposed to be, so they don't turn because they're all loose. Also, when you tighten the packages, it puts little dents in there, and that might be part of the problem. When the dent's squeezing on the belt, it changes its belt's tension. So that might be part of the issue. We're going to find out. As far as getting the belt to grip if it is slipping, this is where you might have a problem. It's not like an automotive belt where you can get belt dressing and it'll work for a while. These aren't automotive belts. You can, and I've seen it done in the past, I have personally not tried it, coat the drive gears in rubber contact cement and let it dry. It'll add grip. I have not tried it, so I cannot tell you if that will work or not. I'm hoping just tightening these packages so they don't turn on the belt, and because it pulls the belt in, will add the tension necessary to keep them from slipping. This one could go a little tighter, yeah. See, they're all relatively straight. Yes. So let's see if this belt has more tension now. No, she's still slipping. So, I guess we'll have to do the next thing. Also, the other reason the belt's getting caught is this belt's been sitting for a while in one position, which is the problem with drive belts. It always relaxes into the same shape. So to make it go past this shape and go to this shape, you can see there's a bow which changes its resistance. So if these were more aggressive, they might dig in better, and that might be the problem with that one too. These little guys, you can spin them. You see now it's facing the other way. As an example, I'm going to tighten those up too. It's the same process to unscrew it. The 4 screws hold on the conveyor. This doesn't have to come off. This is screwed separately to it. But since this belt's still slipping, I guess we need to find a way to make it grip. So I might try the rubber contact cement test, which I have some right here. And you only want to put it on the drive side, which is this side, the side with the gear. Again, this pulley is just decoration. So I might try that, see if it works. The great thing about rubber contact cement, if it doesn't work, you can just peel it right off. So that's why I doubt it in my head that it's going to function. The other option is maybe covering it in hot glue and smoothing it out, because hot glue will provide grip, and at the same token, if it doesn't work, you can peel it right off. So I'm going to do some testing and see what I can find out that might work. I'm going to get this side unscrewed. As you saw how you do it, you unscrew the 4 screws, put it on its side, and the side that has the drive, which would be right here, these pins should pop out just like this one did, and there should be 2 screws to pull the whole side off. So don't try and pry it. Like I said, the only reason I was prying the edges was to see if they would break free, because all I could see was these pieces right here, which are inside these cups, and that's how they are on Limax. I haven't taken apart a Mr. Christmas conveyor belt till now. So to save on time, because everything I do slower again, I'm going to do the rubber contact cement first, let it dry for a few minutes so it's not going to stick to the belt. And if that doesn't work, I'll peel it all off, clean it, and I clean using rubbing alcohol. For those who haven't seen the previous ones, anytime I clean something off, I use isopropyl alcohol, 90% or stronger. Clean it so we have a good mating surface. So I'll clean it, try the rubbing, the contact cement. If that doesn't work, clean it, try some hot glue. And as the hot glue is cooling down, smear it into the teeth. Because if you do it when it's super hot, you can get burns. Or you can use a tool, such as a spudge or a screwdriver. And then try that and see if we can get this belt not to slip. And if this belt doesn't slip, then we should be able to do the same to this belt. Now, as far as this gear, where the crack is, since the gear came out with the shaft and it slid out of this, I'm probably just going to put a dab of super glue in the crack. I've shown in the past where you take a small, like electronic screwdriver or a piece of sandpaper or a needle, and you scrape the crack so the crack is no longer parallel, it's more of a V, kind of like this. And you fill this with super glue and it bonds the gear together. Because gears like this are harder to find. Aggressive teeth gears, they do make packs, but to try and find one that's the same tooth and same diameter isn't always easy. You can get lucky, but so if the gear's still holding to the shaft, just carefully grind the crack and fill it. It works for a lot of the odd size gears, and it saves you money. You don't have to buy anything if you already have super glue lying around. If not, you have to buy super glue. And then I've showed it before, I use the brush, because that way when I cut that groove in there, I can unscrew this and then dab it with the brush, and then if there's any excess, I can wipe it off with a piece of paper towel, so it's not on my fingers, and then let it harden, and it hardens within a couple of minutes. So that's where we're at the moment. So I'm going to do some tests on what works best on this pulley drive pulley to stop these from slipping. I have heard of, and I know it is possible, but not on pieces like this, where you can get this pliable by getting it hot. Usually you boil it in water. I've never tried it, but it might be worth an attempt. If you're going to do something like that and the parts are screwable, unscrew them. Don't boil the rubber to change its rigidness with the packages on it or the little toy figures. Lee Max's example does not screw them on like their hideous toy factory. They're glued on, so you have to break the glue off and then glue the pieces back on. At least that's how it was for the one I bought. I do know, just like everything, every time they build them, they find problems and they change them for the next set that they push out. So that's why there's different generations of houses that are slightly different features, but it's the same house. So first I'm going to see if we can just do the gear, drive, assembly, and if that doesn't work, maybe we'll unscrew all these packages and see if we can make this belt pliable again with some really hot water. When I mean really hot, we're talking almost boiling. So I might also do a little bit more research on hobby belts to see if I can find something else that works for the hobby belt. If they make a hobby belt dressing, I don't want to use an automotive belt dressing. One, I don't like them, and it only is temporary. So, but I want to see if we can make this belt so when it relaxes more in a circular shape and not such an oval shape. All right, I'm going to do some testing. Be right back. See what we can do to get this thing working like it's supposed to. All right, the boiled belts are now installed and they have the pieces all put in, but it's still not working quite right. The squeaking sound you hear is the two belts, when I boiled them, they did shrink, and you can see it's working a little bit better. This one's making a sound because it's almost tight enough to grab, but it's not tight enough yet, so it's slipping on the little teeth. Without the characters or the boxes screwed on, they spun perfectly fine. But once I screwed on the moving mass, which changes how the belt functions, they now stick. And you can see this one's trying, and then a little help. So I'm debating on trying to boil them again and see if I can get a little bit more shrinkage out of them, or try and figure something else out due to the fact that making the drive stickier didn't work. The rubber contact cement, it didn't work. The motion started peeling it off of the drive teeth. Lee Max uses a spring tension barrel that pushes underneath so that the belt stays tight, and as the belt stretches it keeps tension. It's very similar, if you ever work on a car, to a serpentine belt where it has a tensioner. These don't have tensioner, so if this belt or that belt stretch, they just slip. And boiling rubber does increase its tension. It shrinks the rubber, which it did. These belts, especially this one's a lot smaller than that one. And the reason I chose this belt over here versus putting it over here was all these are the same size. This has different size things that are screwed to it. So I wanted a tighter belt that might have a harder time rotating because the mass varies every time it goes around one of the bends, to be on that side. And it is trying. And like I said, if I unscrew all the little things, which you have to disassemble it to do it again, the belts spin totally fine. They never stopped. So once we add mass, though, the belts are having a problem. So now we need to resolve that. So I'm debating on if I should try boiling them again for another 8 to 10 minutes, see if I can get a little bit more shrinkage out of them, or if I should try. I had a suggestion from the other guy that works with me on these, the redhead, doing something like this, putting a little bit of liquid electrical tape on the two sets of teeth, because when it hardens or dries, it gets really tacky. My concern is the tackiness, if this sits for a long period of time, like in storage, that it may bond to the rubber. That's my only concern. Whereas hot glue and yeah, stuff, the others. Oh. It's amazing how you forget things. Rubber contact cement, sorry. Won't bond to the rubber. So, also the belts probably look darker because when you boil the rubber, it removes all the dirt and impurities. So the belts are now actually darker black. Also removes any oxidation from the rubber. So it revitalizes it. So, yeah, there's a whole bunch of different things they suggest for shrinking rubber and making it fit. You can use a heat gun or a hair dryer, but you got to be very consistent with your swipes or else you can cause it to wrinkle, buckle, or melt, which we don't want to do. It's not like you can just go replace these. Boiling it is the best option, and then setting it on something to conform, which is why I stuck it on that round bottle, was to help remove the pre-bent from sitting on these tight rollers. I am thinking about a tensioning wheel, because if I do use a screwdriver and put a little tension in the middle on the sides when it's rotating, it rotates just fine. The belts are just too big. They've stretched too much, and they're vulcanizing, where they're getting rigid and slick. That's the other problem. Boiling does revitalize them, but it hasn't revitalized it enough. It has done more to this belt than this belt. So now we're going to move on to the next set of testing, which is I'm probably going to take it all back apart, boil them again, see if I can get any more shrinkage out of them. And then I might see if we can design a tensioner for it, which would be on the bottom side so you wouldn't see it. It would be underneath, not on the top. But something to add a little bit of tension to help with this slack. There's supposed to be some slack, but I'm taking no resistance to push this all the way down to touch the other side of the belt. That's just too much. So, yeah, and this one's almost the same. It takes a little bit more tension due to it's a little bit tighter due to the fact it's tighter. So this one's a unique one in the sense that it's not like a broken gear, which they are cracked. And again, we'll put some super glue on them after we clean them with I use a X-Acto knife to prevent the crack from spreading into the teeth. Right now it's just on the nose, which is that piece that protrudes out. And other than that, the drive belt, which is underneath, which is floppy, even though it's slipping, or looks like it's slipping, it's still strong enough to turn everything. So it's just kind of a unique situation where it's not something that's easily rectifiable by just buying a new piece or finding a new piece and sticking it in. We have to actually shrink the rubber or retension the rubber on something that's not designed to be tensioned beyond the factory. So I'm going to go back to the drawing board, play with it some more, see what I can find out. Welcome back. I have surrogate hands doing this, as my hand is out of commission. Yeah. So we found a way, as you can see over here, it's working finally, after many attempts on how to keep this from slipping. I boiled it twice, which did shrink it down, but it's still not tight enough. We tried belt dressing, which didn't work. It's the automotive stuff, which I said I don't like previously. So now we're using liquid electrical tape, which gets sticky.
Yeah, it's stuck to my hand.
So we're going to show you the process on how we got this belt to stop slipping on the second conveyor belt.
So we take the belt and I flipped it around so I could paint it on. Most liquid electrical tapes, of course, come with a brush applicator. Knock off most of it because you don't really want a thick coat. And I just put it through my fingers and held it snuggish and just painted it on. Just pull it down. Make sure you get as thin of a coat as possible. We're just going for a little grip. We're not going for, because you don't want to put too much resistance on the belt. You still want it to move freely. You can wear gloves for this if you don't want to adhere liquid electrical tape to your fingers, but
I would recommend the nitrile gloves or latex gloves, not garden gloves.
yeah.
That way you still have your dexterity and you can feel what you're doing.
Once you have a nice coat on there, you can use the heat gun here from the rework station.
If you don't have a heat pen or a heat gun or it's too hot, you can use a hairdryer. Be aware this off gases a lot, so you're going to want to watch your area. Don't do it in an enclosed room with no circulation or ventilation, like us.
Yep.
Liquid electrical tape will dry on its own, but it takes a long time. This speeds up the process and allows you to see if you have any high spots that you can knock down before it's solidified. This will give you extra grip and extra thickness on the belt. So you got to be careful if it's got guides that it's not too thick for the guides. I would recommend boiling them at least 10 minutes. I ended up boiling these belts between the 2 attempts of doing it a total of 20 minutes. After the second boiling attempt, they shrunk down to their smallest size, but they would still slip intermittently. You can see how long this one's been running with the electrical tape change, and it's still going.
Yeah, got a nice, just even brushing on. Now you flip it back right way. Close up the electrical tape so it doesn't dry out and turn into a bottle of rubber. I guess first I should put the
toys back on. So the different things that were attempted was rubber contact cement on just the pulleys, didn't work, peeled off. Rubber contact cement on the belt, didn't work, peeled off. Then it got caught up in the mechanism and it's a mess. Hot glue, it wasn't smooth enough and it was lumpy and kept getting caught in the guides because it's hard to smooth hot glue since it keeps those glue strings that keep coming out when you release your nozzle. Tried just boiling them, still slipped. But the boiling does one other thing, it cleans the belts. It removes all the impurities from the belts, all the dirt and dust in the pores. I wouldn't recommend drinking the liquid that comes out, but you know, if you like rubber soup, there's your base. But the liquid electrical tape seems to be the best setup so far. They do make the stuff called tacky, which is designed for rubber belts and conveyor belts, but unfortunately it's really expensive. And they have to sell it to a company that we found, and you have to buy 5,000 units. So unless you have a company that's going to use a lot of this stuff, try and find a cheaper alternative. Most of the belt tacky stuff says it rehydrates and lubricates the belt. I'm not trying to lubricate the belt, which is why we stayed away from the ones on Amazon. The belt is not dehydrated, it's not cracking, nor is it rigid. It's slipping because it's slightly oversized from years of use. So
again, most of the automotive ones also rehydrate and lubricate. That's the other problem.
Yeah, the STP I just showed you a second ago says it's make your belt tacky, but it didn't make this belt tacky. And it could be it's a different type of rubber from a V-belt or serpentine belt in a car. This is more like rubber, not like a rubber band elastic, but more like if you cut an inner tube.
Yeah, that's what I was just going to say, inner tube material. Inner tube rubber.
And this is the longest part. Reassembly is always the longest part, which is why usually we pause the camera and put it back together. But what this is doing is showing you how long it's taking us and that this thing is still going, because before it wasn't. Also make sure your toys and your packages are square, because the groove in the bottom of the plastic base is narrower than the belt drive. If any of these things are cocked sideways, they catch the plastic, which will cause your belt to slip.
Also, when you put them back together, make sure you face all the toys in the same direction. So that way you don't have backwards bears and stuff.
Yeah, you could face them.
Yeah.
I wouldn't turn the train sideways.
No, or the house. The house is a rectangle.
I could serenade you with Christmas music. I have the volume turned off.
I'm good. It's not Halloween yet. It's not time for Christmas. Even though Hallmark Channel has apparently started playing Christmas movies.
Neat. So they don't make... Most of the Halloween movies they would have are probably not appropriate for Hallmark.
Yep. So this goes on this way. And the toys are going to move that way, so I want to make sure I put the toys so they're heading into the...
Toys are coming the other way.
Really?
The toys come out of here and into the bag.
Oh, okay. Oops. Shows me what I know. This is why Captain Chaos does it, not me. I'm just Mr. Hands today.
For a while.
Apparently.
Toys come out of the present chute into the center and comes out as wrapped gifts.
Oh, yeah, I see the gear hits it like that. Mm-hmm. Yep. Then the side piece goes on.
And the fat screws on the brown pan.
Yeah, except I got the belt caught on the
guide.
There we go. Now the belt's not caught on the guide.
So.
What's catching? It's like a... Why is that not moving? It's like something's catching.
I think it's because the belt's vulcanized. Getting hard.
Yeah, it only catches on the house. You can feel the catch. It's like it's tight when the house
in the train. You can see the belt lift. Just the tension on the screws. You can see how the one, like the ball's pushing down.
Maybe that's it. Apparently the presents have no problem.
That was a screw on the house. Is it tight, loose?
Tight.
Back off of here, maybe. Yeah, I think the presents and stuff for tensioning guides because it changes the angle of the belt.
Come on, line up, both of you. That's getting stuck on a little... Oh no, it's getting stuck because of the house again.
working as a pusher.
Yep.
Turn the belt around.
There's a lot of tension when the house tries to come this way. Everything else flows smooth, then the house really gotta force it.
Excuse me. Let's see what happens if you turn the belt around.
Have this stuff go the other way around.
Mm-hmm. You can always turn the doll and the bear.
Yeah.
The ball doesn't matter.
Train. Come on. There we go. Now the ball's getting stuck.
Or is the train on the top? No.
Huh?
So we don't actually bump it.
I'm just gonna test it. Yep. Ready to get stuck. Bears down there. House. Or no, that's the ball. I have an idea.
Back to the drawing board.
Yep. Alright, we'll be back in a minute once we do some more testing on this side. Alrighty, we're back now. We've tried a few attempts at trying to make this side not slip. It's working, but every once in a while it gets caught and it hesitates for a second. We've put more liquid electrical tape on. We've tried putting a drive belt on or something to give more grip, but it seems to, the belt with the toy seems to hesitate no matter what we do. We put some liquid electrical tape on the drive gears in here to try to see if we can get better contact, but nothing seems to be getting the best contact. So it's unfortunately it's working, because when it arrived here it wasn't spinning at all, correct?
Yeah, you had to help it.
Yeah, you had to help it to get it to spin at all. So right now it is spinning, it just hesitates intermittently on each rotation. The presents, as you see, are spinning nice and smooth. So we are going to finish putting it all back together and
do one last test.
So we'll see you on that one.
Alright, it's back together. See, it's working. The belt still does have a slight hitch every once in a while. Everything we've done to it and for it, it's not being smooth. I believe the belt itself is just too far stretched and hardened, because when it hitches you can see there's a little lift in the belt. I think the only way to fix is to find another rubber belt of the same thickness, same approximate diameter and width, and drill new holes in it for the toys. But when it came in, the belts didn't work, and now they're moving. Also, the gears that were cracked have been filled with glue, like I mentioned earlier, so that they won't continue to crack, and if they do, they won't slip. So, went from mostly not working to working. So as far as it goes, just use the liquid electrical tape. We got this stuff over at the auto parts store. This came from AutoZone. You can get it on Amazon and other places as well. A couple of thin coats. We ended up on the other belt putting more on the belt, another 2 coats to help with its thickness and grippiness. Hair dryer heat gun to dry it quicker, so you don't have to let it air dry. Do it in a well ventilated area. We didn't, but don't follow our lead on that one. And back together, lights, motion, and sound. Oh, it's so festive. So we'll get this one packaged back up and sent back to its owner. Still going? Yeah, look at that. All right, till the next one.